This is the lesson for 1-9, comparing scientific notation. There are three different ways that you compare numbers using scientific notation. This is the less than symbol. This is the greater than symbol. And this is the equal to symbol. So if you think back to elementary school, the mouth opens towards the bigger number. So the bigger number is here and the bigger number is here. You might have learned in elementary school that the mouth or the alligator wants to eat the more M&Ms, but the mouth opens towards the bigger number. So the bigger number goes to the open spot, the smaller number goes to the point. And then when it's equal to, it's equal to. So the first type of question that you're going to have is comparing numbers in scientific notation. And you have to use less than, greater than, or equal to. The number that has the bigger exponent is the bigger number. So we're not looking at any of that. We're not looking at any of that. All that we're looking at are the two exponents. Whichever number is bigger is the bigger number. So you're comparing in this first one, a 3 versus a 4. Obviously 4 is bigger, so the mouth opens towards the bigger number. This answer would be less than. Be careful when you have negative numbers. The more negative a number is, the smaller it actually is. Or you can think of it as the farther away from 0 a number is on the number line, the smaller it is. So we're comparing a -3 and a -4. -4 is smaller, so it's going to be greater than. In this one, we have a 5 and we have a -2. Obviously, any positive number is bigger than any negative number, so the mouth is going to open towards the 5 because the 5 is bigger. So when numbers have different exponents, we need to look at the actual exponents to compare them. So some word type problems. If we're comparing the boat of the Titanic, which is 5.2 times 10 to the 7th, and the Great Pyramid of Giza, which is 6 times 10 to the 9th, we're comparing a 9 and a 7. Obviously, the 9 is bigger, so this one would be the larger number. The Earth's moon is 7.3 times 10 to the 22nd, or Titan, one of Saturn's moons, is 1.3 times 10 to the 23rd. Again, all that we're looking at are the exponents. 23 is bigger than 22. Now, don't get tricked. Don't get tricked. Yes, there is a 7.3 and a 1.3, but we're not looking at those numbers. We're only looking at the exponents. So all that you're comparing is a 22 and a 23. We don't care about that number in front of the times 10. So 23 is bigger. The HIV virus, which is 1.1 times 10 to the -18th, and the E. coli bacterium, which is 1.3 times 10 to the -16th. So all that we're looking at are the -18 and the -16. Again, be careful. The farther away a number is from 0 on the number line, the smaller it actually is. The closer to 0 a number is on the number line when we're talking about negative numbers, the larger it is. So -16 is closer to 0, -18 is farther away from 0. That makes the -16 the larger number. When you have the same exponent, all right, when you have the same exponent, obviously -2 is not bigger than -2. So when you have the same exponent, what you want to do is you need then to look at the number that is in front of the times 10. So now we're not looking at this part because these parts are the same. We have times 10 to the -2nd. When the exponents are the same, you need to look at the numbers that are in front of the times 10 and compare those. 4.7 and 2.1, obviously 4.7 is larger than 2.1. So we have the symbol greater than. In the second one, again, we have the same exponent. We have a 3 and a 3, but these numbers are not equal to each other. You have a 9.3 and an 8.52. 9.3 is larger than 8.52, so this is greater than. So if the exponents are different, you compare the exponents. If the exponents are the same, you look at the numbers that are in front of the times 10. The other kind of question, and this question happens on your state test a lot, is you're going to be asked the question, how many times bigger or how many times larger is one number compared to another number? Well, what you need to do is you need to use this formula. You need to do the bigger number divided by the smaller number. When you do the bigger number divided by the smaller number, you're going to get how many times larger a number is. So if we have the question, how many times bigger is 7 times 10 to the 8th compared to 2 times 10 to the 7th? The 7 times 10 to the 8th is larger because the exponent is larger. So remember, we're doing the bigger number divided by the smaller number. So what we're going to do is 7 times 10 to the 8th divided by 2 times 10 to the 7th. Just like we learned the other day, you can do a variety, you can do 2 different things. If you follow the rule, you do number divided by number in front of the times 10 and subtract your exponents, or you could just type it right directly into the calculator. Be very careful if you type it into the calculator for dividing questions. You need parentheses around the entire scientific notation. So you do parentheses, 7 times 10 to the 8th, close your parentheses, divided by parentheses, 2 times 10 to the 7th, close your parentheses, and then hit equals. If you use the rule, you would end up with 3.5 times 10 to the 1st. If you just use a calculator, you get 35. In these ones, you really want to put your answer in standard form, so 35 is really the preferred answer. I would use the calculator. The calculator makes it much easier to do. And if you really think about it in a word problem, if you're being asked how many times larger is something, well, it's 35 times bigger, all right? You're not probably going to use scientific notation there. So 35 is really the preferred answer. So you're going to have questions like this on your quiz and on your homework. You're going to be given a little table here. So we have 4 different years and how many cars were sold. In which year were the most cars sold? If we're looking for the most, we are looking for the biggest number. Well, when I scan these 4 numbers in scientific notation and I'm looking for the biggest number, I'm looking at the exponents. I'm looking at the 7, the 6, the 6, and the 7, because the biggest exponent is your biggest number. 7s are obviously bigger than 6s, so it's not going to be this, not going to be this. So now I have a 7 and a 7. Well, now you need to look at the numbers because they're tied, they're equal. Now you need to look at the numbers that are in front of the times 10. 2.4 is bigger than 1.8. Now be careful, especially when you go to do your class kick homework. Notice that the original question says, in which year? So are we going to put 2.4 times 10 to the 7th? No, we're going to put 1980 because that's the actual year. If we take a look at the next question, in which year were the least cars sold? In which year were the least cars sold? So this means we're looking for the smallest number. So again, I'm looking at my exponents, 7, 6, 6, and 7. The 7s are obviously bigger than the 6s. I'm looking for the smallest number. These are tied, 6 and 6, so I need to look at the number in front of the times 10. I have a 3.6 and an 8.9. Obviously, 3.6 is smaller. Again, it says in which year, so this would be the year 1990. In the next one, how many more cars were sold in 2000 compared to 1990? So in 2000, there were this number sold. In 1990, there were this number sold. How many more cars? Well, in order to find out how many more of something, you need to subtract the numbers. So if you're going to subtract the numbers, you need to do the bigger number minus the smaller number. So 8.9 times 10 to the 6th minus 3.6 times 10 to the 6th. Again, you could just type it right directly into the calculator if you wanted to, or you could just use the rule, all right? The rule, since they have the same exponent, you would keep the exponent the same, times 10 to the 6th power, and just subtract the numbers that are in front of the times 10. 8.9 minus 3.6 gives you 5.3. That would be an acceptable answer. Or if you use the calculator and typed it in, you would have 5.3 times 10 to the 6th. So that would be 5, 3, 1, 2, 3, 4, 5. It would be 5,300,000 is 5.3 times 10 to the 6th. How many times more cars were sold in 2010 compared to 1990? So now we're looking at 2010 and 1990. When we go to look at this one, 2010 and 1990, we're looking at 2010, 1990. So 2010, there were 1.8 times 10 to the 7th minus 3.6 times 10 to the 6th. The exponents are different. I would type it right directly into the calculator, or you can make them into normal numbers first and then do it. Oh, I screwed up. All right. It says how many times more, not how many more. Be careful. That's a very common mistake. Don't make that same mistake that I just made. It says how many times more. How many times more, you have to do the big number divided by the smaller number. Be very careful in how the questions are worded. I did that on purpose. How many times more compared to how many more, all right? This one doesn't say times, it just says how many. This one says how many times more. So we want to do the bigger number, 1.8 times 10 to the 7th, divided by the smaller number, 3.6 times 10 to the 6th. When you divide those, I would type them right into the calculator. Remember, you need parentheses when you divide in the calculator, and you get an answer of 5 times more. So be very careful there. Go ahead and try these 5 questions, please. Use less than, greater than, or equal to. Remember, the mouth opens towards the bigger number. I'm going to give you about 30 seconds to whip through these. These are pretty quick. Remember, you're looking at the exponents. If the exponents are the same, then you have to look at the number in front of the times 10. If the exponents are different, you just look at the exponent. Whichever exponent is bigger is the bigger number. So when we take a look at this, we have a 6 versus a 9. 9 is obviously bigger, so it is less than. We have an 8 versus a 5. 8 is bigger, so we have greater than. We have -3 and -5. The more negative a number is, the farther away it is from 0 on the number line, the smaller it actually is. So that is greater than. Be careful in this one. We have 6.7 times 10 to the 3rd and 6,700. I would make this one into scientific notation. Type it into the calculator or move your decimal point over 3 places. You get 6,700. So you have 6,700, 6,700. Those are actually equal to each other. We have 2 times 10 to the 6th and 7.8 times 10 to the 6th. Notice that our exponents are the same here. Since our exponents are the same, we need to look at the number in front of the times 10. We have a 2 and a 7.8. 7.8 is bigger than 2, so this is less than. That is the lesson for 1-9. Go ahead and do your class kick for 1-9, please. If you have any questions, school as you message your teacher.